All right, continuing with our quiz review, we're at part 4 now. Characteristics of a polynomial. What is a polynomial? How do we determine the number of zeros or the degree? And let's look at end behavior. All right, so here is a quick reference to what is a polynomial and what is not a polynomial. So I'll put some examples of what is a polynomial. You need to just make sure that your exponents on your variables are not negative or fractions. It's okay to have coefficients that look weird, but we can't have exponents that look weird, basically. Then your graph needs to be a continuous smooth curve, no sharp edges, and continuous means like there are no breaks in the graph. If you start drawing your graph, then you can't lift up your pen or pencil before you stop drawing the graph if you have a polynomial. But these over here are not polynomials for the same reasons, like opposite of what these say. So like my exponent here is a fraction, so it's not a polynomial. This one would have a -1 for the exponent, so that's not a polynomial. And this one, if we simplified, would also have a negative exponent, not a polynomial. And then these graphs are just little pictures of some that are not polynomial graphs because they have sharp edges. And this one is not continuous because you could not draw this without picking up your pencil. So in behavior, let's look at one at a time here. So the main idea is that for any given function, if it is positive and even, and that means we're looking at the leading coefficient when it's in standard form, then it's going to follow the same behavior as a basic positive quadratic function. If it's negative and even, it'll follow the behavior of a regular negative quadratic function. And then if it's positive and it's an odd function, and again, we're talking about the leading term when it's in standard form, then it would follow the same behavior as a basic positive cubic function. And then negative odd would follow the same behavior as a negative cubic basic function. All right, so let's look at these examples here. So in this first example, I put x cubed minus 2x squared plus x. So this very first term, it's in standard form already, is odd just by looking at the degree of 3. And it's positive because there's no negative in front of it, just this first term. So that means it's positive and it's odd, so it's going to follow the behavior of this graph. It doesn't mean the graph looks the same, it just will always follow that same behavior is what we need to remember. So if I think of this little graph, draw it or think of it, whatever I need to do, I need to think about where these ends of my graph are heading. So this end is headed toward the first quadrant and this end over here is headed toward the third quadrant, infinitely so. So this is how I would write that. As x approaches negative infinity, y approaches negative infinity, because that is what the third quadrant is doing. It's negative, negative. And then the first quadrant is positive, positive. So I say as x approaches positive infinity, y is also going to approach positive infinity forever because it's going toward the first quadrant. So example 2 is negative x to the fourth. It's in standard form, but that is my leading term. So I look right there to find it. It's negative and it's even because of the degree of 4. So negative even would follow the behavior of a basic negative quadratic function. So it is behaving, or the ends of my graph are heading toward quadrant 3 and quadrant 4. So in quadrant 3, remember negative, negative, so you write it out formally as x approaches negative infinity, y also approaches negative infinity. And then it's heading toward the fourth quadrant, so that would be positive, negative. So we write it as x approaches positive infinity, y approaches negative infinity. So the next type is a negative odd function because the degree is 5 and it's a negative. So it'll behave like a negative cubic function would. And that means the ends of my graph are up, down, and it's going toward quadrant 2 and quadrant 4. So quadrant 2 behaves like the first part right here. It's negative, positive. So as x approaches negative infinity, y approaches positive infinity. And then the fourth quadrant is positive, negative, so I wrote that out. As x approaches positive infinity, y approaches negative infinity. And then there's one more example. I have a positive even function. So I need to make sure, or I need to describe this one, and it is quadratic, so that just now threw me off, but it would behave like a positive even function, which is like a positive quadratic graph, and it is quadratic. This is just not the exact graph of this one, but we can use this to write out our end behavior. So it's headed toward the first quadrant and the second quadrant. So as x approaches negative infinity, y approaches positive infinity, goes with that second quadrant. And as x approaches positive infinity, y approaches positive infinity, is what it's behaving like over here as it's heading toward the first quadrant. All right, so that's it for those.